Good morning, everybody. The talk title is Drought Risk Assessment in South Asia. Ms. Mary has already given a little brief introduction about me, my work. I'm going to be presenting a general perspective of how drought risk assessment is being done in South Asia, or in general, in global context, and then I'll have a few slides that would discuss the work that I have published last year. So just to start with, when we talk about drought, you would see all kind of buzzwords coming here and there. So the word cloud that you see right now is kind of word that we'll keep repeating when we talk about drought related, hazards, risk assessment, vulnerabilities, and etc. So, there's like in this word cloud, you can see a lot of words here like precipitation, like water, climate, cloud, heat, rainfall, farmers, environment, dry. So these are all terminologies. These are all little important words that would be repeated in pretty much every aspect of description of drought or anything that has to do with drought management. So what is drought? It's basically it's a silent, pervasive hazard which originates basically from the deficit of water availability with devastating impacts on agriculture, water supply, environment, and living beings, causing economic loss. So in comparison to natural hazard, drought tend to be slow, and often comes without warning. It has a significant impact. It lasts for a significant period of time, and usually tend to have a large spatial coverage, and then it may linger for years. And also, it is also difficult to measure in terms of societal impacts. So it has a direct implication on three spheres: atmosphere, hydrosphere, and lithosphere, basically. The hazards associated with drought has to always to do with high temperature, low humidity, loss of soil moisture, low stream flow conditions, and then vanishing streams, lakes, and water table. When we think about climate and hydrology, there are other aspects of hazard that we'll talk later. And the linkages, we can talk about how drought is linked to various associated secondary items, and then losses or risks associated with the drought. So drought is typically linked to phenomena such as wildfires, loss of water quantity and quality. It can lead to famine. It can lead to many other implications. These are not limited to just wildfire, loss of water quantity and quality. And then it has a direct implication on living beings, loss of life, animals, livestock, loss of livelihood, loss of habitat, which would be, like fish habitat, benthic macroinvertebrates, so, trees and other micro and macrofaunas that would rely largely on water. So when we talk about drought, the most important thing that we think about is, there's less water available. So there's few characteristics of drought that we need to know. So basically, drought is generally a natural climatic variability. It has, this flow chart that you're seeing right now describes drought in complete sense. There are many things that you can put in there, but, this is kind of like the most common form of describing drought and characteristics of drought. So basically, it's a natural climate variability, often described in terms of precipitation deficiency. When we say precipitation deficiency, it comes with its own, intensity, magnitude, duration, all these things come into play. It has to do with high temperature, low relative humidity, like greater sunshine, all these things. And they often lead to other implications like, precipitation deficiency, which would literally mean that there's not enough water and therefore no enough infiltration, there's not enough runoff, there's no percolation, there's no groundwater recharge, and therefore there's no groundwater discharge. And then, because of high temperature, there's increased evaporation and transpiration. These often lead to decrease in soil moisture, which means soil has water deficiency now, and then has direct implication on plants, which rely completely on the soil moisture. And then, the other implications are reduced stream flow, depleting groundwater, and et cetera, that I mentioned before. So, this occurs over time. And then these could be also differentiated into different parts of drought and different aspects of impacts, which you can see on the right side. I have divided it into 3 different types of droughts, and then in the bottom you can see different impacts that it can have, like ranging from economic, social, and environmental impacts. So leading from this slide to another one is the one that I was showing at the right, all different types of drought. So when we think about drought, first thing as I said before, we think about water deficiency, and water deficiency can be seen in many different ways. So drought types can be meteorological drought, hydrological drought, agricultural drought, and more recently people have started thinking about socioeconomic drought. So meteorological drought basically is represented in terms of rainfall or precipitation. So precipitation deficit, how dry it is, so degree of dryness, and how long that dryness has stayed, so duration of dry period. Hydrological drought, usually quantified in terms of stream flow conditions, lakes and reservoirs, how much water is available in these lakes and reservoirs, and whether or not the stream goes dry during summer, during the period when it usually gets water from ground surface. So impacts, in terms of impacts, everybody knows what kind of impacts water would be. Agricultural drought has to do primarily with the soil moisture content. When there's not enough soil moisture or enough water in soil in the layer 1 and layer 2 of horizon 1 and horizon 2 of soil, there's not enough water for a crop to grow. So that would directly impact crop productivity. And then socioeconomic drought has to link with all these 3: meteorological, hydrological, and agricultural drought. When we have all these drought, there's a supply and demand of goods get affected completely, and that would lead to economic hardship. So these are 4 different types of drought. I mean, each of them have their own significance. People come up with all kinds of indices to measure all these droughts. I'm going to talk 2 of them here, not everything, given the time. But these are all different kind of droughts we go through, and South Asia have gone through all of these in like various years. The other part of drought that I mentioned, I did mention different types of drought, but then the measures like drought intensity, like what is the degree of precipitation deficit, what's the severity of impact, how much departure did it occur from the normal. How long did it occur in terms of duration, whether it's seasonal, whether it happened for 1 year, whether it has been happening for multiple years, what is it that's affecting in terms of like length of the drought. That's also important in terms of understanding the drought phenomena. And then, if there is multiple time scale, how many years did it happen, which was below normal? And, normal precipitation condition differs from country to country, like and then, like there's other requirement, like if you're talking about agriculture versus hydrology, they differ. And then spatial extent, of course, like how far is your drought extending, whether it is in one region, whether it's for the entire state, or whether it is extending to the entire country. Those kind of things matter when we talk about drought. And impacts of drought especially points to the vulnerable population, especially poor and rural areas, and then also increasing water demand due to urbanization, industrialization, and agribusiness. These these business and these areas would also be vulnerable to drought, and often lead to inappropriate soil and water management. People start thinking about what to do after drought, but then these days there are drought mitigation measures that allow you to think even before drought would happen. Like, how would you proactively manage your watershed or your town or your city if the drought happens? And all of these have to do with the governance. Eventually, how well we relay these messages in science and policy to the right person or decision makers. Now, why do we even care about drought? Globally, there's a lot of costs associated with the drought. Damages associated with drought means $6 to $8 billion every year. More, affects a lot of people. It is multidimensional. It has its impact on environment, economy, mental issues, psychological hardship. All these things are associated with this kind of hazard. Eventually, this has direct impact on food, water, and energy, affecting the nexus, the connection among these three very important, survival mechanism. And then, it can have any other significant secondary and tertiary impacts, like we talk about human health, and then, domino effect that could lead from the, water deficit to the other things. And then there are many examples, drought in Horn of Africa, China, US, England, Wales, and we don't really have to go too far, like in India. I think last year guys did have pretty bad water deficit year. And then the worst one, I believe, was in somewhere in 1918 when 75% of the country was completely under drought situation. So because the topic is about the risk management, I'm going to try to focus more on risk management. But before going into risk management, it's important to know that there is a phase when we talk about drought risk management. We cannot just go into risk management mode without knowing what is the situation, without having monitored data, without starting an early warning system. Once we have this monitoring of drought undertaken, then you can go into a vulnerability assessment mode, and then risk assessment mode, and then only you can start planning for how you're going to mitigate these hazards and how you're going to respond to such disasters. So the causes of drought, as I said, I'm going to repeat these slides further again just to keep bringing this up, is prolonged lack of precipitation affecting a lot of things, and eventually leading to loss of agricultural land, desertification, insect infestations, which I didn't really tell in the beginning, but these are some of the things that keep happening with even a small deficit of water. Doesn't even have to go through the severe drought to go through the insect infestation and loss of vegetation. This slide is just to show you, this is from Willite and Glenn's paper in 1985. It shows you how many times has drought occurred in some of the part of the world. And if I point here, if I point in the South Asian region, you can see in India, you have this, red part, which means that it has occurred from 7 to 9 times between this 1974 to 2004, and then there are some dark colored, like 3 to 4. The western part of India is again 7 to 9. So these are supposedly drought prone area. This does not necessarily mean that the one that are orange or did not have significant drought in the past will never have drought. So this just gives you indication that we need to be prepared, especially in these areas, but we have to think about how to proactively manage water in the other areas which are, not known as drought prone in the past, but could be affected by water deficit in future. These are some of the things that I kept mentioning, which I didn't mention in my lecture. In the few slides is snowpack. Like when we talk about South Asia, the Hindu Kush Himalayas, that's where all the snowpack is in, and most of the rivers that flow to the south, of Nepal and India are snow-fed. So, if there's not enough snow in these Himalayas, then there won't be enough water flowing into these bigger streams. So, snow is extremely important. We don't really think much about snow when we talk about drought, and definitely most of the indices that are currently available don't consider snow as much. Even the best one doesn't consider snow. So there are a lot of room for improvement. So common drought indicators or indices, these are methods, these are tools that are used to come up with a drought indicator, like percent of normal. What is normal for one country is not normal for another. What's normal for India is not normal for United States. India and South Asian region has monsoon kind of weather, so most of the rainfall falls in big chunk in 3 or 4 months, and that's what's important. And whereas in other areas where it's more like the Mediterranean kind of climate, it rains pretty much around the year, so normal differs from country to country. Deciles, every 10 years, how the water, the precipitation work like. Palmer's Drought Index, which is one of the most widely used, widely acceptable index for drought monitoring, which is not very simple. It takes into account a lot of parameters, and therefore many scientists or researchers have difficulty using this particular index because this is not just reliant on precipitation. It requires evapotranspiration and a lot of other information that goes into the equation. I'm not going to go through equation in this talk. Surface water supply index, it's also known as stream flow drought indicator. Basically, this is used for hydrologic, drought analysis. PDI is used for both hydrologic and meteorological drought. And, under PDI, you can see PDSI, Palmer Drought Severity Index. PHDI is Palmer Hydrologic Drought Index, and CMI is Crop Moisture Index. So Crop Moisture Index is the one that could be used to assess agricultural drought. Standardized Precipitation Index, the one that has been most widely used pretty much everywhere, not partly because it uses only precipitation as the input data, and fairly simple. It takes into account the probability distribution function of precipitation, and since it takes into precipitation, it's easy to use compared to PDI. And then vegetation indices, which is basically a like a satellite product. NDVIs, it gives you a sense of what the chlorophyll looks like, what the photosynthesis look like, and if there is good indication of chlorophyll through NDVI, then you would assume that the soil moisture content is good. So that it's kind of inferential. U.S. Drought Monitor, which is a composite index approach, it uses PDI, it uses SPI. It has like combination of few different methods, and they put into a drought monitor, and it's required by most of the water authorities to publish their drought monitor every month and make it public. So why is drought monitoring important? What do we do with these drought indices? It helps us to simplify complex interrelationship. It helps us to provide a communication tool to many audiences. Some of these tools can be difficult to interpret in a lay language, in a non-scientific language, whereas, because it's an indicator and, it gives you this, like from 2 to 7 is dry, from, R2 is dry, -2 is wet, so those kind of numbers are easy to be read by a general public, as opposed to telling people that there is 10 inches of rain, of which 6 inches goes into infiltration, of which 4 inches goes as a runoff. And then if you do not have enough rain, there's no enough runoff. So those kind of interpretation becomes very difficult when you want to talk this to a general public. The indicators help them to understand better. And it also gives you a historical perspective, which could be used for, planning and designing applications. So, I told I'm not going to talk about equations here, but I have one equation in a slide here just to show about the standardized precipitation index. As I said, it's basically a probability function, and the equation, as you can see, is not a complicated one, most widely used one. It's not as difficult one to use. Normalized distribution. So values as, standard deviation from the median, alpha and beta parameters are just the scaling, shape and scaling parameters. They are easy, but then it doesn't give you much insight to the hydrologic drought. Palmer's Drought Severity Index, as I said, this is a little complicated one as it takes into account the evapotranspiration process too. So evapotranspiration can be measured in many different ways. If you're going to be using Habrab's method, you could just use air temperature as your surrogate to come up with a evapotranspiration, whereas you can use Penman-Monteith and Priestley-Taylor method. Those would require additional information such as aerodynamic effect, which would mean that you need more data, more information. And so a lot of people avoid using Palmer Drought Severity Index because they lack those data. And then you also need to have an information on soil moisture content, and that soil moisture content information can be difficult because a lot of people don't do much measurement on soil moisture. If you have, if you're going to use a remote sensing product, the resolution would be pretty coarse. Two other things in Palmer Drought Severity Drought Index is it always considers the first layer of soil as a saturated soil, whereas the second layer is not saturated. So there will not be runoff created until the layer 2 is saturated. So there are some assumptions that goes into the model. It do not assume a frozen precipitation, which means it does not consider snow. Which can be a problem in many places which have snow as a dominating process. So this is a screenshot that I took from drought.gov showing a current condition. This is again using SPI method, which is standardized precipitation index method. As I said, this is another widely used method along with PDSI. It could be presented in many ways. So SPI could be analyzed monthly. It could be analyzed bi-monthly. It could be analyzed in 3 months, 6 months, 9 months. So it could be presented in many different ways. So 3 months, if I'm going to do 3 months on like December, January, February, that will give me a sense of winter drought. If I'm going to do 4 months ending September, that would give me, well, for let's say I'm doing this for India or Nepal, then it would give me a sense of monsoonal season, like what's happening during that time of the year. So another snapshot here is the how the vegetation index look like. So basically, what it is telling you is there are certain VHI, like from 100 down to 0, and then there's the snow and ice, which you can see here, where it's completely dominated with ice. It tells you what is the health of your vegetation. So this is a more recent condition that again, this is a snapshot coming from Columbia University. They have a website where you could actually create a drought index PDSI map, as you just go into the web server. and you can provide the year and month, and you can zoom into the area that you're interested in, and you can get the spatial coverage of drought in a snapshot. So what I'm showing here is how the drought condition was in August 2016 globally, and then I zoomed it to the Asian continent. Tried to zoom into Indian subcontinent here, but I ended up doing a little bigger than just Indian subcontinent here. So what you could see here is the brown. All the brown colors, dark brown colors, indicate that there was a pretty good drought in those areas, whereas the green indicate, in this index line, you can see, green indicator up to 2.8, which means, it's wet, pretty wet. And then at the other end, which is the darkest brown, close to magenta, which is negative 2.8, which means it's pretty dry. So what you can see in this August 2016 year it was from last year, and I know that India and other South Asian countries went through some severe drought periods, and you can see that in this area that the southern India, the entire southern India was under that brown color, which means it went through that severe drought. And you can also see in Nepal, the eastern Nepal was completely dry, and then certain part of Bangladesh, pretty much fully covered there. So this is what happened in last year, August. And then another slide, which is more recent, last month, you can see that difference now. So August is a monsoon season. We would expect it to be wet, but then it didn't happen last year, and we hope that this year we'll get a little wet year. Who knows what's going to happen? But in this picture, you can see what happened just in March, which is just immediately after winter. You can see that we're bouncing back to a little wet season now, and we might see this prolonging, or we might not. There still are certain areas in India. You can see, there's a little patch here which is brown, which means again there's a drought. And then if you look at the African continent, you can see larger brown areas. A bigger portion of Australia went through a drought. Then you have the like South America. Again, and the United States, there's some areas of the United States which had drought situations. So basically, last year we also went through a meteorological drought, like New England states. This one comes from the Indian Meteorological Department. So Bharat Mausam Vigyan Vibhag. I can read it. So. This is one. This one shows. You guys probably are familiar with this picture. This is a report that I believe is made public, and it tells you the aridity anomaly chart, like how arid certain area are. And if it's red, that means it's dry, it's arid. If it's green, it's wet. So it's just telling you like when. So this is from April through October, which is quite a big chunk of time. And then this one is, again, this one's not, I'm reading it wrong. This is June. Okay, this is June 4th to June 10th, and this is June 11th through June 17th. So basically, this is 1 week period. And you can see that there's a huge difference in terms of how arid certain part of the country is. Similar kind of spatial, representation of drought. This is again done through this was done through SPI method, and you could see that a different. This is June of 2009, and the actual precipitation amount here is 84 millimeter, whereas the normal should have been 182 millimeters. So it's a lot less than what normal is, basically 52% less change, and that means it went through a bout of drought. Again, this one is July 2009, a similar condition where you have this normal condition of 293, actual is 278. I mean, not as drastic as June is, but still you can see in this picture the anomaly. You can see a lot of red areas. So this red area is the drought-stricken area, and then Western Ghats, you can see how red it is. August. So I'm showing you how it was in during the monsoon period, when you need to have a lot of rain, which is pretty much important for agricultural productivity and sustaining the country, especially in the subcontinent. And you can see here the normal range is 262. It's again down to 190. This is 2009. So I do not have a latest picture on this kind of picture for India, but as I said, the one that I showed you before, the one from Columbia University, you could actually generate this kind of pictures using that web server. September, not much happening again. There still is deficit in water. So this is again, this is, I would say, more recent. This is what's happening yesterday. Okay, so this is again coming from NOAA.gov. There are different places in, like internet that you can get approved data, approved Drought Monitor. Like the one that I showed you before, Columbia University. This is NOAA.gov. You can get some, insights to what's happening. The pixel-wise, resolution might be coarse, but you can get a snapshot of what the SPI index look like for 3 months, for 6 months, and for 9 months in different part of Indian subcontinent. You can see that, this is actually a monsoonal time where you can see that the southern India, this is not the recent one, sorry, this is from last year. This southern India has pretty much red color, which means it's gone through that bout of drought. Now I'm going to show you some of the slides, which the work that we did published last year. This is the work that a few of my students in Nepal did as a part of my USAID project, where we were looking into how small livestock would be affected due to climate change, and how do we adapt these small livestock holders, and how do we prepare them in terms of preparing them to drought, heat stress, extreme rainfall events, what kind of mitigation measures need to be applied. And this study was done as a part of the climate, like water management group that I led. So the work was conducted in central Nepal, which is a part of Ganges Basin, which all of you probably know. And it has a huge elevation gradient, as you can again see, the Himalayas, and then the southern Nepal, which is close to the border of India. This particular Gandak region is, again, agriculture dominated. Large number of population residing in this area. We had basically 3 different sites in this area where we did a lot of field work looking at livestock feed and fodder management. We installed meteorological stations in these sites. We also had a demonstration plots where we implemented drip irrigation system to help farmers manage their water. And so this is an outcome, one of the outcomes from our work, where we started looking at precipitation and stream flow data for some of these sites. And so the spatial pattern of rainfall in this central Nepal, was done in the simplest possible way. Just did a little kriging of precipitation data to come up with what it looks like. So you can see that the upper Himalayas it's pretty arid, and then you go down to the central area is the one that's wettest, which is close to Pokhara and Shansa area. And then as you go down, Kapilvastu, Lumbini, which is the border of India, seems to be doing okay in terms of rainfall. but this is where there's dry. This is just looking at the, like the 40 stations and averaging 1981 to 2012. And then we looked at, again, we looked at rainfall and stream flow, and all the parameters that would be important to understand drought and extreme precipitation events. And in this case, we looked at, what the precipitation looked like annually, how it differs in monsoon, because our interest was mostly on monsoon, in fact, like how much water falls during monsoon and how things have changed so far in monsoon. But what we've observed is, especially in central Nepal, given the data, that kind of data that we have, we didn't really see much change in monsoonal season, but we did see a decreasing trend of precipitation in winter, which you can see in this is December to February. You can see that there is a decline in winter precipitation. And in terms of spatial representation of the trend of annual precipitation, what you can see is central Nepal, this is central Nepal, center of central Nepal seems to be doing okay. The blue up arrow is the one that shows increasing trend. And the bigger arrows mean significant increase, like this. There's a significant increase. And then the red ones, that's opposite. The big red ones are significant decrease in precipitation, and the small red ones shows decreasing trend, but not significant enough to even statistically present. So what we can see here is there's a mixture, but a lot of red dots here, which you can see that there is decreasing trend in the annual precipitation. That's total precipitation. That does not necessarily mean that we are not getting enough monsoon, or it's quite possible that the timing is being changed, which the study doesn't really tell much. This is like variation of departure precipitation from mean, like how much is departed. Again, presented the same way as before. How much variation is there in annual rainfall, monsoonal, and then winter precipitation. And then we did this man-candle sequential slope test, sand slope test, to look at what kind of changes can we see. So this one is abrupt changes in precipitation. Solid line represent progressive, and dot line represent retrograde series of candle tau, which means there is some issues during this precipitation event. And again, this is what we need to focus most of the time. These did not really show any significant change. This is what showed a significant change, and you can see in this particular graph that the trend line is declining. This is a winter precipitation. This slide is just like, as we said, SPI was the method that we used in this paper, the simplest possible method, partly because the precipitation data was readily available. We did not have enough information on soil moisture data, or we did not want to go into that territory for this paper, I would say. And then, the Palmer's Drought Severity Index, as I said, require a lot more input data as opposed to SPI, and SPI does a pretty okay job to represent the drought conditions. So this is just to show, like, SP12, which is taking annual data, SP3, which is winter, which is December, January, and February. Actually, the SP3 at February is right here. This is SP4 at September, which is 4 months monsoonal data. All you can see here is winter precipitation is decreasing. Everything is in red. There are only few ones that are in blue, and then there are significant one. Monsoonal precipitation is kind of mixed result for us. There are some places in the eastern central Nepal where you can see some decrease. So this is close to Kathmandu area. And then this, you see a lot of decrease in these areas. This is Sangja and Pokhara area, Kabul Bastu Lumbini area, where you can see some decrease. And the same data we presented in many different ways, and we now wanted to know how many percentage. So there were 40 stations that we looked at, and out of 40 stations, how many stations actually showed that there was drought occurrence in monsoon and winter. So this bar chart actually tells you like how many percent of the time the stations actually showed. So basically, the dark black is the occurrence of monsoon, and the gray one is occurrence during the winter. And then you can see that, there's only one year, a couple of years here that you can see 1991 and 92, where the monsoonal drought seemed to be apparent, and similar 2004, which is actually a global drought year, 2004 and 5. But then you can see winter kind of stands out here. And then presented similar, results in a spatial distribution way to look at like what spatial extent was affected. So we looked at intensity, we looked at like the duration. This is like what's the extent of the coverage of space, the drought. 2004 and 5. 2004 was the start of drought globally, I would say. And then 5 seemed to be pretty ugly. Here you can see a big patch of, like the entire central part of the central Nepal is drought-stricken. 2007 seems to be better, kind of wet year, and then 2009 is again another drought year. So you can see that mixture of drought and the wet years here. Now, based on these information, it's important, once you have the monitored data, these are basically monitored data and the indicators developed in order to assess vulnerability. Now, we know hazard, so it's a probability of occurrence. How often would it occur? What is the specified area of occurrence? What kind of damage can it have? That's hazard. And then vulnerability would be what kind of people, what's the characteristic of people, what kind of activities would be impacted. If we're talking about living beings, what kind of environmental impact can it have? What kind of economic impact can it have? And, what can we anticipate in terms of coping mechanism, whether there is a possibility to recover from the impact of drought or not. So that comes into vulnerability part. And then the risk is where usually risk is the product of hazard and vulnerability if we think about the, equation. But these days, people have started adding in more than just hazard and vulnerability. So this is what it's going to look like. So elements of risk. So you have hazard and, like how long somebody is exposed to that hazard, and then, and then that leads to vulnerability. And then also it's very much location specific. So certain locations might not have a large population, and therefore the vulnerability wise, they would be less, even if there is high exposure of hazard, so the risk in general would be less. But if certain location has large number of population, large number of fish, large number of aquatic habitat, they would tend to be more vulnerable under certain hazard. And then depending on how long things are being exposed, that risk would go up. So these are elements of risk. Next is unacceptable risk. Like most of the risk hazards will have impacts that we would call unacceptable, but some of them are severely unacceptable. So decrease in water quality, unacceptable. Definitely water quantity, which is not acceptable. Susceptibility to wildfire. So I'm showing you only certain dimensions here. There are more than just this 4 dimension. You can think about a lot of things here. So economic loss, famine, death, public health, infrastructural damage, if it happens. All of these need to be assessed when risk assessment is being done. And then once the risk assessment is done, then there is where you have monitored data, you have risk assessment done, and then you prepare for mitigation. And mitigation and preparation kind of is sort of like, it's a government thing. It has to work with the working group, you have to have stakeholders, all scientists get together with decision makers, and then it becomes an organizational structure. So a lot of the time internationally, there will be a drought commission organizational structure. In the US has the organizational structure too. India probably has it too. So you would either work at state level or at the central level. But at any level, there will be a monitoring committee, there will be a risk assessment committee, there will be working groups, there will be stakeholders, and at each level there will be assessment report, resulting in a drought commission. So now this leads to a question. Now, I'm not going to talk about policy here. After talking all these, monitoring techniques, vulnerability and risk management and risk assessment, how do we make use of this data, these kind of information, to come up with a drought policies? I'm sorry, I have a little typo there that should be developing. There's an L missing in that developing. So what are the challenges for developing national drought policies? Now, this would be questions for students who are listening to me right now, to start thinking of, if you are going to do drought assessment, if you are going to do research on different types of indicators, how would you use those indicators in helping develop national drought policies? What kind of information can you provide regulators? What kind of information can you provide stakeholders or decision makers? What are the institutional arrangements necessary in order to develop such policies? It cannot be just done at a scientific level. It cannot be just done at a political level. It has to have the mixture of everybody. It has to be an integrated process. So what is the kind of institutional arrangement that's needed? And what type of steps should be taken in developing such policies? If you're going to come up with a mitigation plan, if you're going to come up with a proactive management of certain disaster, then how do you undertake that proactive management? So these are the kind of questions that often, it's not easy to answer, but it requires a work, work which I showed you before, like 3 steps where you have a monitoring, and then you have vulnerability assessment, and then you have, finally you go to mitigation and planning. And then that's where after that is when the policy level of decision takes into place. So this pretty much ends my talk. I am ready to take questions. Thank you for listening to me.